Let's get to know our world. We are talking about black holes, which have an enormous gravitational force. When we talk about a sky body with such an interesting feature, the question of how black holes are formed inevitably comes to mind. How do dark vortices in space form? The violent explosion experienced by massive stars in the last period of their lives is called the supernova explosion. A star exploding as a supernova throws 95% of its mass into space, while the remaining ones contract. Their surfaces acquire a bright white color and keep their warm state. Such a shrunken and collapsed star appears dim from afar, and they are called white dwarfs. When a star contracts into a white dwarf, if its mass is about an average solar mass 1989 times 1030 kilograms, it ejects matter in its outer region in the form of gas clouds with a small explosion. A white dwarf star can explode violently during the contraction phase. The electrons in the atoms of such a star cannot withstand the pressure on them. The electrons combine with protons and form neutrons. Thus, nothing remains in the star other than a neutron. Neutrons in the star are compressed until they touch each other. At this stage, although the star is the size of an asteroid, pieces of rock in space, its mass can be up to 10 solar masses. Astronomers call the stars formed by collapsing in this way as neutron stars. If the shrinking mass of the star is very large, for example 30 solar masses, neutrons in the star cannot withstand the gravitational force and become even more compressed. The gravitational force here is so high that the star closes into itself and its volume becomes smaller. Some cosmic objects with great gravitational force rotating around their own axis in space bend both space and time in their immediate surroundings. Scientists call this phenomenon the Lense-Thirring effect. Stars with very large mass bend and contract the space around them like a heavy cannonball left on a sheet surface. This phenomenon is so severe in black holes that space collapses and becomes almost a bottomless well. Space is torn and pierced. If we think of the universe as a flexible fabric, an iron ball weighing tons left on the fabric will puncture or even pierce the fabric like a cone. Black holes also hollow and pierce the universe just like this iron marble. This pitting effect of the black hole, that is, its size, is entirely related to the mass of the star forming the black hole. For example, if our Sun were compressed into a sphere with a radius of about 3 kilometers, that is, a volume of 4/millionths of its size, it would become a black hole. In fact, if we could compress our Sun to a volume of 1 cc, we would have made a 1 cc black hole this time. But in this case there would be no change in the orbital movements of the planets in our system. In other words, the planets in our solar system would continue to rotate in their orbits at the gravitational force of this 1 cc black hole equal to that of the Sun. It is understood from here that the bending property of a black hole in space-time, or its capacity to absorb the surrounding celestial bodies, is proportional to its size. Here, can a nearby star turn into a black hole and swallow our world? You may think of an inquiry like, "Our world was created by Allah's will, away from such a danger." A possible ingestion does not seem possible because even the closest star to us except the Sun is far away and small. Black holes in space have such a strong gravitational field that they absorb and swallow whatever is in their immediate environment like a tornado. Even light cannot escape from this gravitational field. Since it absorbs and absorbs even self-emitting light, they are not visible from the outside. If you could look at them, you would see a black void that absorbs everything around it. For this reason, scientists today call these cosmic vortices black holes. How are black holes detected if even light cannot escape from them? In our galaxy, stars are often found in pairs and orbiting each other. If one of these pairs of stars is a black hole, matter flows from the other star to the black hole. Since the gravitational force is very large close to the black hole, the energy of the matter rotating around it becomes too much, and this energy starts to radiate by turning into heat with friction. When the temperature rises to billion degrees, the radiant emerges as a flood of X-rays. This could be called the scream of a dying substance. In fact, detecting and identifying a black hole is not as complex as it seems. Because black holes can be defined with very few parameters. This is one of their amazing features. Only 3 parameters are sufficient to describe a black hole in the universe we live in. These parameters are mass, electrical charge, and angular momentum. Since 1967, black holes have only been defined by these 3 parameters. All other parameters, size, shape, etc., of black holes are determined by them. However, in order to describe a planet in space, hundreds of parameters such as its chemical composition, differentiation of elements, convection, and atmosphere must be known. This indicates how special the planet we live on is. Because the continuation of life is always possible with these parameters having a certain value. A deviation in a parameter means the extinction of life. The first observation of an object containing a black hole was made by the Uhuru satellite in 1971. The satellite detected a source of X-rays in the binary star Cygnus X1, the brightest star in the constellation Cygnus. It has been determined that the largest black holes are located at the centers of galaxies. Black holes here can have a massive mass of up to several billion solar masses, and in this case they are called giant black holes or galactic black holes. Although there are giant black holes in the centers of galaxies, this does not mean that the larger the galaxy, the bigger the black hole in the center. The second largest black hole astronomers have ever seen is clear evidence of this. The NGC 1277 galaxy is 1/4 the size of the Milky Way we live in. However, there is a black hole 4,000 times the size of the hole in the center of the Milky Way. The mass of this hole is about 17 billion times that of the Sun. While black holes are known to cover 1,000th of the density of the galaxies in which they are located, the newly discovered giant black hole makes up 14% of NGC 1277's density. The width of the giant black hole is almost 11 times the area where Neptune orbits in its orbital motion around the Sun. This is quite an astonishing size that the research team who made the discovery thought that they had detected the density of the black hole incorrectly, and made evaluations that took a year to confirm the accuracy of the results of the research. The event horizon and the relentless gravity of black holes have a strong gravitational field called event horizon around the funnel mouth. anything that falls into the event horizon area is taken in. In other words, there is no turning back for an object that falls within the event horizon. The impact area of the event horizon increases in proportion to the mass of the black hole. The larger the mass of the black hole, the larger the surface area of the event horizon. For instance, the mass of the Sun's mass radius of a black hole, which is equal to only about 3 kilometers. A star with a mass of 10 solar masses is 60 kilometers in diameter. When it collapses into a black hole, have an event horizon that happens. As a black hole engulfs matter, the event horizon expands, and the larger the event horizon, the stronger its gravitational field. The point at the very center of the event horizon, where all the matter of the black hole is gathered, with infinite density, is called singularity. The singularity point is the most effective region of the black hole. At the point of singularity, gravity approaches infinity. According to the calculations of scientists, the density value is known as 1094 gr per centimeter 3. Considering that the density of water is 1 and iron is 7, this value is mathematically considered infinite. In this case, the black hole is in the form of an infinitely deep well or funnel in the space-time universe environment. Today, exactly what happens at the center singularity of a black hole, and what laws of physics work here, is unknown. On the other hand, thanks to the various indirect methods applied, the physical conditions prevailing in its immediate environment and its effect on the environment can be perfectly defined. Scientists, like matter, ends in the singularity of the black hole. So time stands still. In this place where time stands still, the laws of physics also lose their validity. The gravitational waves released by a black hole capture and absorb everything around it, and it gets bigger and bigger. As it grows, its gravitational field increases and it swallows other black holes, stars, planets, and even galaxies around it. This means that it is technically possible for the universe to eventually disappear by being swallowed by a giant black hole left alone. Black hole at the center of our galaxy and the measured orbit of the Sun. All stars in our galaxy, including the Sun, are 44 million kilometers in diameter. As determined by 9 and Sagittarius A** named galaxy rotates around the center. The Sun, and of course, with it, we are constantly rotating around this center. It is estimated that it took approximately 230 million years for the Sun to complete a single orbit around this center. Well, what is in the center of the galaxy around which 200 billion stars revolve? At the center of our galaxy is a giant black hole with a mass 2 million times the mass of the Sun. This black hole devours all the stars around it with its magnificent gravitational force and eats them. Scientists state that it will take only a second for a black hole of this size to swallow our Earth. The fact that there are more than 1 million black holes in our galaxy, 11, and that none of these have crossed paths so far shows that our mighty Lord always protects us from such great dangers. Because even a black hole engulfing our world, even approaching it, will disrupt the balance of the solar system and cause the planets to leave the orbit of the Sun and disappear into cold and dark space. In this case, the Earth will die by holding ice in space. Of course, the only danger to the Sun and the planets that follow it is not limited to being swallowed by this black hole. As the black hole engulfs the stars approaching it and adds its mass to its mass, it sprays jets of hot gas, including X-rays and gamma rays, along with high heat into the depths of space. In the gas jet oscillation, energy is released as jets along the black hole's rotation axis. These gamma rays from the black hole are very dangerous. So much so that, even a gamma-ray rain that lasted just 10 seconds would burn off 25% of the ozone layer. Even this would lead to the disruption of the world's food chain and the mass death of living things on Earth. The disk of accumulation, which surrounds the black hole and is often a luminous ring, is also a source of threat in itself. The accumulation disk is millions of degrees hot and scatters X-rays like a thermonuclear bomb. Although X-rays do not carry as high energy as gamma rays, they are harmful enough to kill living things on Earth. Radiation hazard aside, it is impossible for a planet orbiting a black hole to receive enough heat and light to sustain life. The Sun's orbit around the galaxy is different from billions of other stars. The Sun follows a circular orbit in the center of the galaxy. In other words, it neither gets closer nor goes far from the center. If it were, our world following the Sun would be exposed to enormous dangers. The orbit of the Sun in space is a special path that Allah created with care. Astronomy professor Guillermo Gonzalez explains the features of this magnificent creation as follows. The Sun travels between the Sagittarius and Perseus spiral arms of our galaxy. If our place were on the spiral arm, we would be exposed to active star bursts that could be deadly to us. If our path were closer to the center of the galaxy, the result would still be fatal. The high radiation from the black hole in the center of the galaxy is very dangerous for life forms. If the orbit were further out of the galaxy, our Earth would never exist, as these are in conditions that do not allow planet formation. If we were closer to the center of the galaxy, as Gonzalez mentioned, life on Earth would not be possible due to the high radiation. The harmful gamma rays, X-rays and cosmic rays emanating from the center of the galaxy would not leave a single living cell. However, our solar system is about 28,000 light-years (266 quadrillion kilometers) from the center of the galaxy and is safe and away from all these harmful effects.